section 2.5-Zeros of polynomial functions. I've always believed that if you put in the work, the results will come. Michael Jordan. In section 2.5, we're going to be looking at finding the zeros. And so let's look at some definitions. If f(x) is a polynomial of degree n, where n is greater than 0, then f has at least one zero in the complex number system. If f of x is a polynomial of degree n, where n is greater than 0, then f of x has precisely n linear factors. So basically, if the degree is 3, then you will have 3 linear factors and 3 zeros. The rational zero test, if the polynomial f of x equals to this polynomial, has integer coefficients, then every rational zero of f has the form. So the rational zeros will be equal to p divided by q, where p is the factors of the constant term and q are the factors of the leading coefficient. And with this rational zero test, what's going to happen is it's going to help us to have a smaller list of numbers to check for possible zeros. So in the last sections, we looked at finding zeros, and one method we used was synthetic division. But in the previous examples, they always gave us at least one zero. In these examples, we're not going to be given a zero. And so first, let's look at some examples for the rational zero theorem. So the first thing we're going to do is determine all the factors of the constant term. So again, the factors are just the numbers that you can multiply to give you that term. And all the factors of the leading coefficient. Then we're going to divide them. And then that's going to create our possible list. So let's look at example 1. So the first step is to identify the factors of the constant term. So my constant term here is actually -4. So this is our constant. And the factors for -4, we're going to write them as p. The factors are 1 plus or minus 1 and plus or minus 4, because 1 times 4 is 4. And then we have plus or minus 2. 2 times 2 is 4. We don't need to write the 2 twice. And then we're going to look at the factors of the leading coefficient. So my leading coefficient here is going to be 2. So we're going to call this q, and the factors are plus or minus 1 and plus or minus 2. Now that we have our p and q, then the theorem says that the rational zeros would be given by p divided by q. So p is plus or minus 1, plus or minus 2, plus or minus 4, and q is plus or minus 1, plus or minus 2. So our possible zeros is the quotient here. So we have 1 divided by 1 is 1. 2 divided by 1 is 2. 4 divided by 1 is 4. 1 divided by 2 is a half. 2 divided by 2 is 1, which we already have. And 4 divided by 2 is 2, which we already have. So here our answer is the possible zeros. And so we have 1, 2, 4, and a half, both positive and negative. And so what this helps us to do is to only concentrate on those 8 possible zeros. Then we test them, see if any of those are zeros, and then we can break down the problem, which we'll do in a little bit. Let's look at example 2, list of possible zeros. So again, the factors of P is going to be the factors of the constant, in this case plus or minus 1. And for Q, it's the factors of the leading coefficient, so in this case plus or minus 1, plus or minus 2. So we divide P divided by Q. So P is plus or minus 1, Q is plus or minus 1, and plus or minus 2. So our possible zeros are 1 divided by 1 is 1, and 1 divided by 2 is a half. Okay, so in this example, we have 4 possible zeros. Example 3. List all the possible zeros of 4x to the 5th plus 12x to the 4th. So here my P is going to be my constant, which is -3. So the factors are plus or minus 1, plus or minus 3. And the factors of Q is my leading coefficient, which is 4. So here it's not asking us to find the zeros, it's just asking to find the possible zeros. So we divide P divided by Q. And so my possible zeros will be 1 divided by 1, 3 divided by 1, 1 divided by 2, 3 divided by 2, 1 divided by 4, and 3 divided by 4. So these would be your possible zeros. On your web assigned homework, you're going to need to put these from, I believe they ask you from smallest to greatest. So they'll want you to list these from smallest to greatest. So what is the point of this rational zero test? So the point is to find the actual zeros. And so we use that test to reduce the number of possible zeros that we can work with. So here's the steps for finding the actual zeros. So first we use the Rational Zero Theorem. Then we use synthetic division to find a zero. And then we find the rest of the zeros using the quotient. So for example 4, step 1 is find the possible zeros. So my factors of P are 1, and my factors of Q, which we use 4, is plus or minus 1, plus or minus 2, plus or minus 4. Divide PQ. So we get that our possible zeros is 1 divided by 1, 1 divided by 2, and 1 divided by 4. And so that's step 1. Step 2 is to use synthetic division using one of these possible zeros. So I always like to try 1 first. If 1 doesn't work, then I try -1. So we'll try 1 first. So we have a 4. There's no x squared, so I need a 0. -3 and -1. Bring down the 4. 1 times 4 is 4. 4 plus 0 is 4. 1 times 4 is 4. Plus -3 is +1. times 1 is 1, so we get a 0. So if we get a 0, then that should make us happy, because that means that we have 1 0, and now we can move on to step 3, which is to use the quotient to find the rest of the zeros. So my quotient here, remember we go 1 power less. So if we started with cube, now this is going to be 4x squared plus 4x plus 1. So once we have our quotient ready, then we have options. Since this is quadratic, you can either try to factor or you can use a quadratic formula. So I always tell my students, if you're going to factor, give yourself a minute or two. If you can't factor, then it might not be factorable, so you will have to use a quadratic formula. So this example, we get 2x plus 1 and 2x plus 1. Solve for x by setting each factor equal to 0. Subtract the 1. So x is equal to a negative a half. And this side would be the same. So my zeros are x equals negative a half, x equals negative a half, and the third one comes from, since we got 0, then that makes this a 0. Okay, so notice the degree is 3, and we have our 3 zeros. Okay, let's go to example 5. Find the zeros. So again, step 1, possible zeros. So our p is negative 2, and our q is 1. So my possible zeros here is 1. Oh, we need to divide. So they're going to be 1 divided by 1 is plus or minus 1, and 2 divided by 1 is plus or minus 2. Okay, so now we go on to step 2, and we test using synthetic division. And so again, I always like to try 1. Bring down the 1. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. Plus negative 5 is negative 3. Times 1 is negative 3. So 1 plus 1 is 2. 2 times 2 is 2. Negative 3. And so negative 2 plus negative 3 is negative 5. So notice we didn't get a 0. So that means that 1 is not a 0. So then I try negative 1. Bring down the 1. 1 plus negative 1 is 0. Times that is 0. Negative 5 times 1 is positive 5. So that doesn't work either. And so let's try 2. Bring down the 1. 2 times 1 is 2. Plus 1 is 3. 3 times 2 is 6. 6 plus negative 5 is 1 times 2. So we get 0. So the number 2 is a 0. So now our quotient is going to be x squared plus 3x plus 1. And so at this point, we can factor or use a quadratic formula. Notice here that we cannot factor this because of the 1. 1 times 1 would never give us, if we add them, 3. So our only choice here is to use the quadratic formula. Okay, so recall the quadratic formula is this here. So if you substitute the values of b, a, and c, your answer is going to be -3 plus or minus the square root of 5 divided by 2. So my zeros are x equals -3 plus square root of 5 divided by 2, x equals -3 minus square root of 5 divided by 2, and your third zero is x equals 2. As a review, remember these all have multiplicity of 1. Since they only appear one time, so the graph is going to cross at each point. Okay, so let's look at example 6. So step 1, the factors of p is plus or minus 1, plus or minus 25, and plus or minus 5. For q, we have plus or minus 1, plus or minus 2. So my possible zeros will be p divided by q, which is plus or minus 1, plus or minus 5, plus or minus 25, divided by plus or minus 1, plus or minus 2. So here we get 1 divided by 1 is plus or minus 1. 1 divided by 2 is plus or minus a half. 5 divided by 1 is plus or minus 5. 5 divided by 2 is plus or minus 5 halves. And 25 divided by 1 is 25, and plus or minus 25 halves. So this is our possible zeros here. So we pick one for the synthetic division. And so I'm going to write it up here. So we have 2, -15, 23, 15, -25. So we bring down the 2. 2 times 1 is 2, plus -15 gives me -13 times 1 is -13. 23 minus 13 is 10 times times 1 is 10. So we get 25 times 1 is 25, and then we end up with 0. Since we have a 0, that means that x equals 1 is a 0. So now we look at our quotient. So we go one less power since we started with 4. Now this is going to be 2x cubed minus 13x squared plus 10x plus 25. So notice here that our quotient is not quadratic. So we cannot use a quadratic formula, or we cannot factor this, or if you want to try to factor by grouping, you can. So if this is not possible to factor, then we start the process over. So we would find the p and q, the possible zeros. Notice that I have 25 and 2, which is what I had at the beginning. So I can still use this list here. And so since I already used 1, I'm going to go ahead and use -1 and see if that works. Again, you can use any number in this list. I'm going to bring down the 2. 2 times 1. -1 is -2 plus -13 is -15 times 1 is +15. 25 times -1 is -25. So we get 0. So that works. And so now my quotient would be 2x squared minus 15x plus 25. Okay, so now we can use the quadratic formula here, or we can try to factor. So let me get another sheet of paper so we can have more space. Okay, if you use the quadratic formula, we would have negative b, which is negative 15, plus or minus negative 15 squared minus 4 times a times c divided by 2 times 2. Negative negative is positive. Then we have 15 times 15, which is going to be 225, but let's double check. 15 times 15, 225. 4 times 25 is 100, times 2 is 200, divided by 4. 225 minus 200 is 25, divided by 4. Square root of 25 is 5, divided by 4. So one answer here is 15 plus 5, divided by 4, and your other answer is 15 minus 5, divided by 4. 15 plus 5 is 20, divided by 4, which is 5. And 15 minus 5 is 10, divided by 4, which is 5 halves. So my zeros for this problem, we should have 4 because the degree is 4. So one zero was x equals 5. The other is x equals 5 halves. And I got those from here. Then we had x equals negative 1 since I got 0. And x equals 1 since I got 0.